All right, so in this module, we're talking about how to name acids. Nomenclature part 3. Well, first of all, what do we mean by an acid? At this point, at this level, the way you will be able to tell that a compound is an acid by looking at its formula is the first element written in the formula will always be hydrogen, H. Think of it as a cation, H+, because it pretty much acts that way. And so these would be two examples of acids, and you would know that by looking at them because they both start with hydrogen. So there's two categories of acids that we're going to talk about when we're naming these acids. Where the anion, which is the second part, everything after the hydrogen, does not contain an oxygen, or the other situation is where that anion does contain an oxygen. We'll start out with the situation where the anion does not contain an oxygen atom. All you have to do then is fill in this blank right here. So if a compound is an acid and the anion, that is everything after the first 1, 2, or 3 hydrogens, H, H2, or H3, does not contain an oxygen, it's always going to look exactly like this. Hydro, then there's going to be something in here, then IC, then acid. What goes in the blank is just the root name of whatever the anion is. So these three right here, these are all acids. We know that by looking at them because they start with H. And none of these, the rest of this would be the chlorine, the selenium, and the CN cyanide would be the anion for each of these. None of them contain oxygen, so we're just going to fill in the blank with the root name of the anion. Chlorine, or chloride is the anion. The root is chlor, so we write hydrochloric acid. This one here, the anion is selenide, so we say hydroselenic acid. This is one of the polyatomic ions that I asked you to memorize. It's called cyanide, so it's hydrocyanic acid. What about these? Going the other way from the name to the formula. Pause for a second, see if you can write down the formulas for these acids. By the way, when you're looking at the name of a compound, you know it's an acid. It's real easy because it always will have the word acid in it. And you'll know that the anion does not have any oxygens in it because it will always start with hydro, have some root, and then it'll always have IC, and then to say the word acid. The only thing that differs in these is the root. So hydrobromic acid, hydrothiocyanate acid. Well, bromic comes from bromide, and bromide is Br-. And remember, we're treating the hydrogen as a cation, it has a +1 charge. We still have to balance the charges, right? So 1 and 1 makes it HBr. With the hydroselenic acid, by the way, kind of going the other way, selenium or selenide has a -2 charge, so when we balance out the charges here, we get H2 Se. Notice that 2 has nothing at all to do with Hofbrinkel, okay? It's just balancing the charges. And then hydrothiocyanate acid, if you look in your table of polyatomic ions, thiocyanate is either SCN- or NCS-, doesn't matter. 1 negative charge, 1 positive charge from the hydrogen. Balance out the charges and we get that formula. All right, so now, what if the anion does contain an oxygen, 1 or more? Well, to say the names of these, all we're going to do, is find the name of the anion. And the anion in this situation will always be a polyatomic ion. So look in the table, which you hopefully have started to memorize anyway, the table of polyatomic ions. Find the name of that polyatomic ion, change its ending this way. There's only 2 possibilities if it's a polyatomic ion and it has an oxygen, 1 or more oxygens in it. The name will always end in either ATE or ITE. So you look up the name of that polyatomic ion. If it ends in ATE, you change the ATE to IC. If it ends in ITE, you change it to OUS. Ate to ick, ite to us. And if the polyatomic ion has sulfur or phosphorus in it, like sulfate or phosphate, sulfite, phosphite, then what you're going to do is you're going to also add, for sulfur, add a UR back in. For phosphorus, add an OR back in. So sulfate phosphate becomes sulfuric or sulfurous, and sulfite becomes sulfurous. Phosphate becomes phosphoric, etc. So, we look at these. We know that they're acids because they each start with hydrogen. So to name them, we look at the anion. In both cases, there's one or more oxygens. So we know we're going to have to find the name of the polyatomic ion, which is just the rest of the molecule. We're going to change its ending and then say the word acid after it. So pause for a second, see if you can write down the names for these acids, and then let's go see. So H2SO4, the SO4, you look up in your polyatomic ion table, is SO4 2-, it's called sulfate. Okay. And sulfate becomes, remember we add the UR back in, becomes sulfuric acid, and we say the word acid. Here, in this compound, the polyatomic ion is IO-. This is one of the ones in that second table that I asked you to memorize. It's called hypoiodite. I should write these guys down. So hypoiodite is the name of IO-, and so we change the ITE to OUS, and it becomes hypoiodus, and then we say the word acid, just like that. All right, going the other way. Okay, so now from the names to the formulas, we see the word acid, so we know it's an acid. It does not start with hydro, so we know that the polyatomic ion has oxygens in it, which means it's a polyatomic ion from the table. So pause for a second, see if you can write down the formulas for these names. All right. So phosphoric, okay, the phosphoric IC came from A to E, and now we're going to take the OR back off and we get phosphate. You look up the formula for phosphate. It's PO4 3-, and again, you're going to memorize these. So what we do is say, okay, there are 3 negative charges, so because each hydrogen has a +1 charge, we need 3 hydrogens. Easy as that. 3 negatives, we put 3 hydrogens in front. H3PO4 is phosphoric acid. Nitrous acid, OUS, came from ITE, so we look up nitrite. It's NO2-, 1 negative, 1 hydrogen, HNO2, nitrous acid.